After we have a general understanding of medical statistics, we will begin to study statistical methods to analyze data at hand. We know that data analysis involves descriptive statistics and inferential statistics. In my later class, we are going to focus on the descriptive statistics, Chapter 2. In this chapter, we will introduce the statistical method to describe the data at hand in some concise way. We expect to extract information from data at hand by statistical description. We know data are not information. Data alone is nothing. Data analysis is more important, so we need to extract information from data. In smaller studies, this step can be accomplished by listing each data point. But in general, this procedure is tedious or impossible. Even if it is possible, this method would not give an overall picture of what the data look like. Methods and skills of descriptive statistics are essential to help us to thoroughly understanding the characteristics of our data that was collected from your research. Before discussing how data can be summarized and displayed, classifying data and identifying different types of data are essential. Different types of data should be analyzed using different methods. So, before studying different methods of statistical description, it is necessary to distinguish between different types of data. So, now let's talk about the types of data in medical statistics. There are 4 types of data in statistics, including normal data, ranked data or ordinal data, numerical discrete data, and numerical continuous data. There are 4 different types of data, but how to distinguish between those 4 types of data? Now, let's discuss one by one. The first is nominal data. What is nominal data? Which type of data is nominal data? Nominal data are data that one can name. They are not measured, but simply counted. Nominal data describe the data in terms of some categorizations, including well-defined aspects of the data. For example, the gender. For example, the gender. There are 2 categories, male or female. Now, if I want to study the gender of your class, now some students are male, some are female. For each student, either male or female, you don't have other choice. You can only choose one of those 2 categories, either male or female. You don't have other choice. Then I count out the number of male ones and female ones separately. Count out the number of students for each group. Maybe 48 female students, 52 male students, maybe. Now, such data, we called it as nominal data. the value of a variable for each observation is marked by a category. Each student choose his gender, male or female. So the value of a variable for each student is marked by categories. And then we count out the number of observations of each categories. We count out the number of students of female and male. So it is the normal data. It is the nominal data. Because the value of a variable is marked by categories, so the nominal data is also called as categorical data because it is marked by categories. So the nominal data is also called as categorical data. We know gender have two categories, male or female. However, nominal data also can have more than two categories. For example, the blood type. We know blood type have four categories: type A, type B, type AB, and type O. There are four categories. For each student, you can choose one of those four blood types. You just choose one. Maybe type A, maybe type B. For all the students in your class, someone is A, someone is B, someone is AB or O. Now, we count out the number of students in each blood type. Maybe type A is 26, type B 32. Maybe it is also nominal data, but it have four categories, more than two categories. Another examples, such as country of origin, racial group. All of those are nominal data, and they have more than two categories. Now, if there is a nominal data have more than two categories, three or more, and those different categories can be ordered in some way. Such nominal data is also called as ordered categorical or ranked data. Ranked data is also marked by different categories. Strictly speaking, ordinal data is nominal data, but this type of nominal data have more than two categories, three or more, and those different categories can be ordered. So we named it as ordinal data or ranked data. For example, if we want to evaluate the effectiveness of a treatment, now a patient may be either improved, the same, or worse after treatment. Now, the effectiveness of a treatment was marked by three categories, and those three categories was ranked from best to worst. So it is ordinal data. It's an ordinal data or ranked data. Another examples such as serious order were mild, moderate, or severe, and best, second best, third choice, and worst. All those are ranked data. This is the second type of data, ranked data. We also call it as the ordinal data. Strictly speaking, it is a nominal data because the value of a variable is also marked by categories, but such data have more than 2 categories, and those categories can be ordered, so we named it as ordinal data. Since above 2 type of data, nominal data and ordinal data are all marked by different categories, they can also called as qualitative data. So qualitative data consists of 2 types of data, nominal data and ordinal data. The value of a variable are all marked by categories, and then we count out the number of observations in each categories. That is the qualitative data. And nominal data can have 2 or more than 2 categories, but ordinal data must have more than 2 categories. 3 or more, and those different categories was ranked in some way. Those are qualitative data, consist of nominal data and ordinal data. Another type of data is numerical data. For the numerical data, the value of observations can be marked by exact numerical value that arithmetic operations can be applied to. We know qualitative data, the value of observations was marked by categories. But for the numerical data, the value of observations was marked by exact numerical values. And according to whether the exact numerical value have decimals or not, the numerical data was divided into 2 types. One is numerical discrete data, and the other is numerical continuous data. For numerical discrete data, the value of observations was marked by exact numerical value, but such value only take integers. It is impossible to take a value with decimal. For example, the number of teeth of babies. Each baby have an exact number of teeth, maybe 10, maybe 6, maybe 14, maybe 16. Those are exact numerical values. The value of the number of teeth, this variable, was marked by the exact numerical value. But now, those values are all integers. The number of teeth, all the values are integers. It is impossible to take a value with decimal. So it is impossible to have 6.8 teeth of a baby. It is impossible. Maybe 6, maybe 7. It is impossible to have 6.6. Such value is impossible. So such data we call it as numerical discrete data. And the number of patients in a hospital, the number of newborns in a country, the number of a child in a family are all numerical discrete data. They are all marked by numerical value, but only take an integer. It is not allowed to take a value with decimal, so it is called as numerical discrete data. The other type of numerical data is numerical continuous data. The value of observations also can be marked by exact numerical values, but unlike numerical discrete data, numerical continuous data allowed to take a value with decimal. It can take any value. It can take decimals. It can be an integer. It also can be a decimal. For example, height, weight. The height value may be 162.46 centimeters. The weight value may be 62.19 kilograms. Those are they are all have decimals. Such data is a numerical continuous data. It can take any value. It allowed to take a value with decimal, so it called as the continuous data. But for the numerical discrete data, only integer. It is not allowed to take a decimal, so it is discrete data. But for the continuous data, you can take any value. It allowed to take a value with decimal. No matter the discrete data and the continuous data, they are all marked by exact numerical values, so they were also called as numerical data or quantitative data. So quantitative data consists of two types of data: numerical discrete data and numerical continuous data. The common of those two types of data was that they can take numerical values that arithmetic operations can be applied to. But if only take integer, that is the numerical discrete data. If can take any value with the decimals, that is numerical continuous data. So now we can conclude that the types of data in medical statistics are usually defined as either qualitative data or quantitative data. Qualitative data involves nominal data and ordinal data. With nominal data, it's the categorical data with two or more categories. Ordinal data have more than two categories, and those categories can be altered. Quantitative data involves numerical discrete data and numerical continuous data. Numerical discrete data only take integers, not allowed to take a value with decimal, but for the numerical continuous data, you can take any value. It allowed to take a value with decimal. Those are the types of data in medical statistics. However, the type of data is not fixed. We can convert one type of data into another. For example, if we wanted to know the age of the Chinese people, age was measured in years. Each person have an exact age value, so it is a numerical continuous data. According to the exact age value of each person, now we can assign each person into different age group. If someone smaller than 16 years, it is a young group. If larger than 65 years, is the elderly age group. Between 16 and 65 is a middle-aged group. So now, all the observations was assigned into different groups. So the exact age value was converted into three groups. Now, those three groups is ordinal data. It was ordered, so it is ordinal data. Then we can continue to classify age as economically productive age group and dependent age group. As subjects in young group and elderly age group are dependent on others. Now, those two categories was a nominal data with two categories. In this process, a numerical continuous data was converted into ordinal data and then to the nominal data. But now, if the original data is age group, we only know the age group of each person. Maybe a young group, maybe middle-aged group. We just know the age group of each person. Now, the age group of each person is a nominal data. Now, it is impossible for us to get the exact age value for everyone. So, we can't convert a nominal data into numerical data because we can't get the exact age according to the age group. We just know they was in this group, but the exact age value is unknown. So now the nominal data can't convert into the numerical data. So when we convert data, it is possible to convert a higher level skill into a low level skill. But we can't convert from a low level to a high level. Which is a low level and which is the high level? The more information that the data can tell us, the high level it is. So the level qualitative data, the level of quantitative data is higher than qualitative data. So we can convert qualitative data to qualitative data, but we can't convert qualitative data to quantitative data. Besides that, because qualitative data offer less information than quantitative data, so after we convert the qualitative data to the qualitative data, will lead to a loss of information, but often make the data easier to summarize. So in your research, you need to weigh the need of converting data. Those are the data conversion. So now this is about the type of data in medical statistics, including qualitative data and quantitative data. Qualitative data including nominal data and ordinal data. Quantitative data including nominal, numerical discrete data and numerical continuous data. And those data can be converted, but you just can convert qualitative data to qualitative data from high level to the low level. Those are about the types of data in medical statistics.